Ladies and gentlemen, please welcome back to the stage your MC this week, Jeremy Gielen.
Good morning, everyone here at 11th Cloud Expo in Silicon Valley. Amazing to see so many of you up this bright and early. Absolutely fantastic. Keep coming if you're drinking that coffee outside. I can see you from 97 different doorways. It's time to come in because day 2 keynote, we have the CTO of Rackspace. I'm going to introduce him momentarily, but first, a housekeeping note. Because is this not the night of the Temptations concert? It is, I hear. So if you haven't had your Temptations ticket yet, make sure you get that at booth 321 on that show floor, where the pretty girls are and the whole Temptations signage is. Make sure you got that ticket because the ticket is going to be also your means to be the winner of that car that you're walking around on the show floor. Have you seen the little car? Wouldn't mind one of those myself. Plus, there is a raffle ticket that you also need to pick up, which will enable you possibly to meet and greet the Temptations. I think it's 7 o'clock this evening, so before they play. So when you get that raffle ticket, that's also important because, you can take your iPhone and send it to your kids. None of that has got anything to do with open cloud computing. So let us switch back to the topic in hand and give it a huge roar, as I say, for the CTO of Rackspace, John Engates, one of our favorite speakers. Yes, the Rackers are here.
I liked Jeremy's music better. It was Stevie Ray Vaughan. I love that stuff. That's from my home state of Texas. I love that Texas music. Well, thank you everybody for having me. I'm John Engates. I've got a slide to tell you all who I am. Jeremy did a better job, but if you want my email address, you can write it down up there, and if you ever need anything from me, just let me know. I work for a company called Rackspace. I think by now most of you probably know who we are, but there's maybe a few out there that don't. And here's the obligatory Who's Rackspace slide. We are a company that came from our roots in hosting, and over the last few years we've really gotten into cloud computing in a big way. I think we're clearly at this point, one of the leaders in cloud computing, and I guess that's why I'm here to talk about cloud today. Cloud computing, cloud conference, cloud expo here. So we're certainly in the right place. What I really want to talk about is sort of where we've come from in terms of cloud computing. In the old days, we used to have a laptop or a desktop. That was the center of our digital world. That was where all of our data sat. That's where we spent most of our time. It wasn't very mobile, it wasn't very portable, but it was the center of our digital universe. It was our hub. In the new world, where we are today in terms of cloud computing, sometimes it's hard to really imagine how far we've come and how fast it's happened. I think back to the early days of Rackspace, and we were, running Windows XP on our desktops, and most of us were still on machines that were tethered to the desk. And nowadays, we've got all these devices. We've got mobile devices, we've got tablets. There's a new tablet out almost every week, and there's lots of devices that even we don't think of really anymore as computers. And they all need a new hub. They all need a new center. And that's really what the cloud has become in the consumer computing world, is the new hub for all of our devices. Think beyond even the devices that we normally think of. We're starting to see connected devices of all sorts, appliances, and I know there are refrigerators and washing machines. I saw them down at Best Buy the other day, connected washing machines. So this has really become sort of commonplace in our world. Our parents know about cloud because they're configuring the cloud on their phones. They know about cloud because that's where their pictures are. And so we all sort of recognize the importance and the value of cloud in the consumer world, the importance of the consumer cloud. I think when a lot of people come to this kind of a conference, CIOs, leaders of IT, business leaders, they come to try to figure out what the importance of cloud in the context of business. Can the cloud help your business? Can the cloud make your business better? Can it do something for you? I think that's why people come here. They want to learn. I think sometimes people get up on stage and they talk about all the benefits of the cloud. And these are I've used this slide for many years, and I'm certainly guilty of using this sort of same old stuff. You know, it's cheaper, it's faster, it grows up and down, you can do things on demand and self-service. And those are all valid. Those are all the reasons why a lot of us want to go to the cloud. But I think there's a lot more to it than that. And I think sometimes we don't highlight that enough. We don't spend enough time on it. So I thought I'd spend a little time telling you about the things, the businesses, the business models that wouldn't even be possible without the technologies of cloud computing, without the services that we all sort of take for granted today. So think about these guys. Media companies, video companies, music, streaming, photo sharing, all of these different sites that we're all familiar with. Their businesses probably wouldn't exist today if it weren't for some of the cloud architectures that we're using nowadays. Things like using low-cost commodity servers, cheap Linux servers, cheap white box servers, machines that don't come from a specific vendor but are just as low of cost as possible. You can't store the kind of amount of data that YouTube has to deal with and expect to do it on very expensive enterprise class storage. You have to do it differently. And so a lot of these guys basically invented their own cloud technology long before most of us really knew what the cloud was. So their businesses wouldn't exist. And there's a lot more. I mean, I threw a few logos up here of people that are either doing business on the cloud or in the cloud or have built cloud technology. But there's a lot more like them in the works. Every day it seems like there's a new iPhone app that's exposing one of these video sharing services. Think about social. Social is another technology set, social and location. A lot of these technologies wouldn't be possible. These companies wouldn't exist if they didn't have access to very low cost, very scalable technology. Facebook, for example, just crossed 1 billion users on their social network, and they have embraced the concepts of cloud computing, the technologies behind it, the low-cost servers. In fact, Facebook started an organization called Open Compute to help drive down the cost of computing, and cloud computing is at the heart of this. Collaboration and communication. In the old days, collaboration meant a server on your LAN where you all shared files. Nowadays, it's a server, it's a cloud. It's a server in the cloud. It's a cloud where all of your files are stored, and you can share them on your phone, and you can share them on your tablet, and you can share them with people all around the world. Also video, again, this is sort of the intersection of that video. This is streaming video, this is real-time video, but it requires very large scale, and it also requires very low cost, because a lot of these business models don't really work unless you can drive the cost out of the infrastructure. This is one of my favorite slides because it talks about sort of the real futuristic stuff, the Internet of Things. There's a coming trend in terms of technology where almost everything, I mentioned washing machines earlier, that things that are going to be connected and communicating with the internet, but it goes far beyond just some simple appliances. You're going to have your car, your automobile connected all the time, full time. This is Google's, down here in the corners, Google's self-driving car. That may be the ultimate example of a connected car. It's got GPS feeds going on, it's got internet connectivity, it knows where it is, it's got awareness of its environment. You've got devices like that thermostat right in the middle. That's a Nest thermostat. I have one in my house, and it basically allows you to connect your thermostat to the internet to be able to communicate with it. But beyond just setting the dial, it also allows the Nest folks to collect a lot of data about what's going on, help them understand the energy consumption, help them drive down energy consumption. I know the utility companies, as referenced up there in the corner, the smart grid, they're trying to enable the nation's energy network to be smarter and more internet connected. All of these things generate data. This thing up in the corner that probably you don't recognize, it's a Bluetooth low energy platform. It's a device that's embeddable. It's hard to gauge the size of that, but that thing is about as small as a watch battery. In fact, the watch battery, if you put it on the back of that thing, it actually takes up more space than the device itself. And that's going to be embedded in all kinds of devices over the next few years. And the significance of that is that Bluetooth module can now communicate with your phone or your tablet, and it can allow your phone to consume data about other objects in your world. There's a heart rate monitor that you can buy now that has that embedded in it, so it sits on your chest, it reads your heart, and it communicates with your phone. Imagine that really almost everywhere, in your light switches, so you can turn on and off the electricity. These are what I call the Internet of Things, because they're all going to be connected to the internet. Wi-Fi enabled cameras. They're all going to be communicating with the internet and therefore the cloud. They're going to be storing data in the cloud. They're going to be streaming data constantly to the cloud in terms of metrics and all sorts of aspects of our lives. Basically, computing is becoming embedded in our lives. It's sort of this thread that goes through the fabric of our lives. Computing used to be a very disconnected thing. You sat in front of the computer or you got up and walked away. Today, we live with our computers. They're in our pockets. They're going to be on our glasses. They're going to be embedded really everywhere. There's devices like the Nike Fuel Band and the Fitbit that are starting to help us gauge our fitness on a real-time basis. This is just the beginning of this human-computer interface that we're all going to have, again, within the very fabric of our lives. All of that stuff that I've mentioned before is creating this mountain of data. You get this term thrown around a lot, big data. Well, what big data means is just lots of data that needs to be stored and needs to be analyzed, and it's beyond the scope of the traditional enterprise tool set that we had before. We used to use SQL databases. SQL databases are not up to the task necessarily for some of these data models. We have billions of records going into some of these data stores because of this Internet of Things, because of this architecture of the cloud and the modern application that we're building. Mobile has driven most of this. If you look back at what almost every one of those categories before relies on, it really relies on a connection, a constant mobile connection to the cloud. I actually love this picture because in some ways these are the ultimate cloud devices. They are only usable with the cloud behind the scenes. If you're on an airplane, it strictly, severely limits what you can do with these devices. You can play a couple games, you can watch movies that are already stored on your device, but you can't do much else because these are cloud devices. They rely on the cloud. The cloud is behind the scenes. The cloud has also changed the way we think about software. Another picture of these devices, but what I'm really trying to demonstrate here is the array of applications that are running on these devices. If you think about the PC that I showed in the first slide, we started with an operating system from one company, and then we layered on a handful of applications from that same company, Word, PowerPoint, Excel, Outlook, and then maybe a couple of business applications that we bought from a vendor of some sort. The ecosystem around these devices is fundamentally different than ever before because we may have hundreds of different applications provided by hundreds of different vendors all over the world, all delivered from the cloud. Think about what that's doing to traditional software as well. I use this as an example. I'll pick on Oracle. They're a great company, but the old way of software delivery was it came in a box. It came in a box, it showed up on your doorstep, and you installed it. Somebody else came and installed it. It took 6 months to install or maybe longer. By the time it got installed, everything had changed and you had to sort of go through that whole that life cycle again. Now, most companies are figuring out, Oracle is doing a great job moving to the cloud, but this company has done probably the most spectacular job in demonstrating the power of software in the cloud. It's the idea that you can consume software through a web browser and the software is constantly updated. It's constantly changed. In fact, it's a very different relationship than software used to be. Used to be that I talked to my vendor only when I needed something. Now, my vendor knows all kinds of information about me, who I am and where I work and potentially where I'm located and how I use their product and what buttons I click. And it's really, there's this entire spectrum of data that they're collecting. And they're collecting it because I'm connected to their cloud. I have access to their cloud and they have the data that's streaming out of it. Bring your own device. Everybody recognize that term? This is the collision that you're seeing going on between enterprise computing and consumer computing. This is me bringing my device, bring my device to work, and hand it over to the CIO and say, connect me to the internet, connect me to the cloud, connect me to your applications. What this is really doing to the CIO, though, is forcing him to live up to the same standards, the same expectations that all those cloud applications are living up to. On demand, access anywhere, on any device, high speed access to my data, really just an entirely different set of expectations for the modern CIO. And so this is why I think today that the CIO is really looking to the cloud. It's not just to save money, it's not just to solve a few problems with getting access to servers faster. It's really trying to live up to those same standards that all the big internet companies are doing today, the Facebooks, the Googles, the Apples, the guys that are really driving the consumer. So, the last bullet point, I think, in terms of competition, this is a picture of one of Facebook's data centers. You see the little open compute logo. I told you about this earlier. This is probably the last thing that a CIO nowadays wants to have to compete with, is a low-cost, massive-scale data center that's in a green location where they've got renewable energy, they've got top-notch security. A CIO has a room that was given to him 30 years ago in an office complex that he calls a data center, but it really doesn't resemble the modern data center, and it certainly can't keep up with the demands of being a good global citizen, from a green energy source. And I think that's probably the other reason that a lot of CIOs are looking to the cloud. They don't want to build and own data centers anymore. They certainly don't want to buy and manage hardware in a aging data center. So when I put all those slides up there, to me it feels like the world is speeding up. It feels like it's no longer sort of a linear kind of progression that we're on. The path used to feel like every 3 years or 4 years we'd get a new operating system, we'd learn some new stuff, and then we got back to work. We got back on our normal cycle. But nowadays it feels like every day there's something new coming out. Every day there's a new app, there's some new technology that we have to learn. It feels like the world is definitely speeding up. Here's some statistics that I think maybe help demonstrate why that's happening. The internet, every 5.32 years it will double in size. So that is based on what I talked about, devices, people. The globe is all becoming connected. People all over the world are on the internet, and it's doubling because of it, and also because of the nature of what's being connected. It's no longer just humans, it's devices. So this is the number of devices that they predict will be connected by 2020. 50 billion devices. That's why we had to go to that IPv6. IPv4 couldn't keep up with the number of devices that were going to be connected to the internet. We ran out of IP addresses. YouTube, they upload 72 hours of video every minute. Every single minute there are 72 hours uploaded. You can't store that kind of data on a traditional storage architecture. You have to use something different. Content, the amount of content that's on the internet, 540,000 times more content now in 2015 than there was in 2003. Here's a great example of a company that's doing something big on the internet. Their business model wouldn't exist without the internet, and it just really shows what's possible. This is a company called Gadget. They do a online gadget site. They cover all of the latest announcements from the likes of Apple and Google, and they sit in the audience and they blog real time about what's going on in these keynotes, and they give their commentary. And they, in a 2-hour period, when they announced the iPhone 5, the guys at Gadget went from 0 hits to 55 million hits, and then back down to some normal amount. And again, their business wouldn't be possible without it. It costs them about $200 to run this event every time Apple does a big keynote, and that's really unthinkable if you tried to do it with last generation architecture. Pinterest, or I'm sorry, is this Instagram or Pinterest? I can't remember. It is Instagram. Instagram was collecting 10 photos per second during the Sandy crisis. I think they're up to 800,000 images total that were tagged with the name Sandy during this recent crisis that we've had. Again, another business model that just wouldn't have existed without cloud. This is probably the most classic example of what's going on, the growth of cloud computing. Today's the election. Users here in the US of these technologies, back in 2008, Facebook had about 44 million users that were over 18. Today, that number is 143 million users. These are voting-aged American citizens. Twitter went from 3.4 million to 24 million. How could they possibly do this kind of growth without cloud technology, without access to some of the, the best minds helping them build their technology? Not everybody has those experts on staff. Not everybody can afford to recruit the top names out of Google to come work at Facebook and the top names out of Facebook to come work at Twitter. We have to actually do this on other technology, on other clouds, on other people's, and I think that's really what draws a lot of people, obviously, to Rackspace. So, the question that a lot of people has, I asked this earlier, can the cloud help your business? I would argue that more and more the cloud will become your business. You will have a business that is inherently fused or tied to a cloud in some way. Even companies that manufacture what we think of as old world devices. There's a tractor company, they make farming equipment. That farming equipment nowadays is connected via GPS and via internet links to the cloud. The modern farmer wants to know about how his fields are performing, how much yield he's having in each acre of land, where he should spray the pesticides, where he should do the kinds of things that farmers do. And he wants that data. He wants big data to help him with that. And so even a tractor, which we think of as sort of a 20th century, maybe even a 19th century device, is now a connected device. It's a cloud device, if you will. And so I would argue that most businesses, now there may be a few examples that people can throw at me that say, no, they'll never be connected. But almost everything will have some inherent cloud connection. You are going to sit on a cloud somewhere in some facet of your business. So with that in mind, sort of thinking about the cloud becoming this language or this highway or this infrastructure that's going to power our future, whether it be consumer or business, if we think about that, shouldn't everyone have equal access, equal rights, equal language, common language to speak about cloud? If it's really that important to the future of humanity, shouldn't we all have sort of an equal stake in all of this? I think that's really what leads a lot of people to this question of lock-in. You hear this term a lot at conferences, lock-in. Lock-in means is that you're basically building on a proprietary platform that locks you into a particular vendor, single vendor. The vendor doesn't want you to leave. They want you to use their products. They want you to use their products exclusively. And so they build irresistible products that lock you in. And this is happening to some extent today. There's a lot of great products out there that are single vendor solutions that do lock people in. I think maybe a great way to explain how this is different than the past is in the past we used to have applications that sat on top of infrastructure. This is a good analogy, maybe a rider on a horse. If we didn't like our vendor, we could switch the hardware out for a different vendor. We could switch vendors and the app stayed the same. But today what's going on is the applications are starting to fuse themselves to the cloud. They're not just sitting on top and can be migrated simply. They're starting to really reach down into the application stack, the platform stack that are underneath, and start to use things that are unique to the cloud platforms that are underneath. It's not just a like-for-like exchange anymore. And this is really because of this idea of programmatic access. When we think about cloud computing, we think about automating things and creating API integration with the cloud so that we can drive the cloud with our application in mind. The application can add more resources, the application can remove resources, the application can repair itself by creating new instances. That's what programmatic access is all about, and that's one of the most powerful aspects of the cloud. But that programmatic access has that flip side of potentially locking you in. And that lock-in, in the analogy I like to use for this, is this Avatar movie. You remember Avatar a few years back? This Banshee is the name of this creature. And instead of just sitting on top, you actually fuse to that Banshee. Do you guys remember the movie where he kind of plugged his hair into the Banshee and he became sort of one with this device or this animal? And this is kind of how people, I think, today are starting to think about cloud computing. They are fusing their application to the cloud. And I think that's good and bad. It has that flip side of potentially locking you in. Hardware is really becoming software. Hardware is becoming something that is so far behind the scenes nowadays that really all we think about nowadays is the software. And because of that, we have the potential to get locked in. Now at Rackspace, we never really believed in the idea of lock-in. We always looked for alternatives to single vendor solutions or proprietary solutions ever since the early days of Rackspace. And so when we started to think about cloud computing, we thought about the problem that we had. How do we turn these racks of standard hardware into a cloud? And we looked out there in the market for open source solutions. At the time, this was probably 2 or 3 or 4 years ago, we looked at all the proprietary commercial solutions. The good news for us is that there really wasn't anything out there at the time that would lock us in. There wasn't that many solutions out there. So we ended up building a lot of that technology ourselves. Now, our roots, going back to our history, we were a company that was built on the web. We were a web company. We had web customers. Our customers were building applications using the LAMP stack, the Linux, Apache, MySQL, PHP. They were using all flavors of open source software. Obviously, some commercial as well, but the internet, in my mind, was really kind of built on the open technologies, and Rackspace was as well. And so what we started to see was that we were going down this path, if we were going to build our own software, that we were going to basically become a proprietary vendor ourselves, and we didn't like that idea. We thought the cloud shouldn't be something that was closed and locked in. It shouldn't be something that individual vendors kind of held their customers hostage. We saw an opportunity to sort of do what we did in the early days when we were using Linux, and what Linux really pioneered, which is the idea of open platforms, open computing architectures. That's really put the power back in the hands of the user rather than in the vendor. And that's important because if we're really truly going to be a world that's connected via the cloud, do we really want to have a platform that we have to call a vendor and ask for permission or buy his solution for access to the cloud? I look back at that example of the internet. Think if we had to buy a license to be on the internet. Think if countries all around the world had to come to one company and sign up and pay a fee to be connected to the internet. It wouldn't be the internet that we know it today. And I'd like to think that the cloud is one of those things that needs to develop in a lot of the same ways that the internet did, in a very open way, in a very inclusive way. This should not be an exclusive set of technologies that are only available to people that can pay the fee. This should be something that you should have access to and be able to build the cloud your way. And that's really why we took that software that we built and we donated it to the open source community. Rackspace is one of the founders of the OpenStack project. This conference, I walked around a little bit. It seems like there's a lot of OpenStack here, but Rackspace was really one of the original founders, us and NASA. We started this project a couple years back, and OpenStack has become a very vibrant and powerful force. 2 years ago, it was a handful of companies. Today, it's over 650 organizations now backing OpenStack. Now 6,000 developers contributing code to the most recent project. I know Jonathan Bryce was up here yesterday talking about OpenStack, so I won't go into too much detail about what it is, but the point is that this has become the open alternative to the closed and proprietary clouds. The ecosystem, I mentioned ecosystems earlier, the Apple ecosystem, you see how powerful it is. You see how powerful Android is, and those are the only two platforms almost that matter at this point. I think Apple and Android have probably combined 80 to 90% market share. Ecosystems are critical to platforms, and having an open, inclusive ecosystem, I think, is critical to the future of cloud computing. Having vendors bringing their own technologies to the game rather than being locked out, being inclusive of all different types of technologies and really driving this innovation. I think Rackspace is a great example of somebody using cloud computing to power the public cloud, but there are so many different business models out there. You're going to start to see more and more businesses built on the cloud, and obviously they need access to that technology. And this powerful ecosystem brings together all of the different vendors, all of the different solutions, and even people that are just interested in contributing in some fundamental way. Maybe they aren't even a vendor. Maybe they're just an individual that's interested in cloud. This is the ecosystem today that we've built around OpenStack. Obviously, that we're very proud of the names that are on this list. There's lots of great companies that you'd recognize. They're driving forward the OpenStack ecosystem. They're making sure that you have the technologies that are going to resonate for you. It's not just one vendor, one way. This is a choice that you have now. You have numerous vendors that are going to package OpenStack in different ways that are going to be right for your business. There are going to be storage vendors. There are going to be security vendors. There are really literally every type of company out there now pushing OpenStack and making sure that it has a future. Rackspace, this year we really consumed our own product. We built OpenStack for us, but we weren't completely on OpenStack until this year. And so this year was the year that we moved all of our products over. The last two on the list, Cloud Servers and Cloud Networks, just launched maybe a week and a half ago. So we're very proud of being the largest contributor and also the largest user of OpenStack in the world. Now the contribution part is going down over time because there's so many more people now contributing, but we're still at this point one of the largest consumers of OpenStack and really on the leading edge of this. We're taking advantage of the latest, greatest projects. There are obviously a number of sub-projects within OpenStack, and almost every one of these is sort of a targeted or built on one of these sub-projects, and we're leading the way in that regard. We're also leading in terms of private clouds. I think sometimes we talk about the things that we can do in our data centers, but there's also things that you might want to do in your data center. Even though you may not want to build another data center, you probably still have one. You probably still have servers and people and equipment and space, and it probably has a useful life of probably another 5, 10, 15 years potentially. So what do you do with that data center? Well, you want to make that look like a cloud as well, and that's what we heard from companies all over the world when we were talking about OpenStack. Help me build a cloud like you have, but just put it in my data center. And so that's why we launched this private cloud software. Rackspace Private Cloud Software basically takes all of our expertise on OpenStack, it distills it down into a package that you can download and you can install on your own data center equipment, and it's free, completely free. We don't charge for it. The only thing we would charge for if you wanted it was for our support in helping you run it if you chose. But the software is free. Now, the success of this has been staggering in terms of the number of downloads. We posted our private cloud software, I think August 15th was the date, and between August 15th and now, the software has been downloaded thousands of times from all over the world. Literally almost I think every continent is represented. I don't think this map does a good job at that, but every continent, including Antarctica, is represented in the downloads list of who downloaded OpenStack. So there's a lot of interest in this, and I think this interest stems from the fact that people are looking for an alternative. They're looking for to have a choice in the way that they deploy in the cloud. They want to make sure that they're not getting locked in to a particular vendor or a single source. 25% of the Fortune 100 have downloaded this, plus hundreds of colleges, universities, research centers, all different types of organizations. And this really speaks to the fact that cloud computing today is sort of one size fits all, and it may not be right for every organization. Big enterprise companies in the Fortune 100 and research universities and small businesses all have different sets of needs. They all do different things with their computing platforms. And I think that's yet another powerful aspect of OpenStack, is that it can morph and can really change to meet the needs of almost any kind of environment. And that's why I think there's so much interest in it. So our vision that's being realized as we speak, is the idea of having Rackspace power public clouds using OpenStack, deploy private clouds, and even third parties build clouds of their own. We embrace the idea that there will be competitors out there. That's a good thing. It's a good thing for you that there are competitors that are going to have software stacks based on OpenStack, because that means you have choice. That means you're not locked in to a particular vendor. So connecting all these obviously is part of the picture too, to make sure they're interoperable, to make sure that you have the ability to move your workloads from on-premise to off-premise to a competitor cloud. So I ask you, are you a cloud company? I think the better question maybe is, are you an open cloud company? Or do you believe in this idea of open cloud? I hope you do. I hope you realize that this is the future of computing. You all have a role in it. You all have a stake in it. You all have a say in it if you choose to go down the path with OpenStack. And the future for us is open. We think the future of cloud is open, and we appreciate your time today. Thank you.
Thank you so much, John. We have time for Q&A, and I just want to say to people, don't leave your seats. You'll find out why, and like, good for you bringing the rear of the room into Cloud Expo. So, here's a build-up. Oh, take my one. You wanted one that worked?
Yeah. So something which is not spoken about is support for cloud. Because when a company, let's say, puts its infrastructure on the cloud, and when something goes wrong, then just waiting for the support to get back to you, even when you have to respond to your management, it's not the best experience at this point in time.
You've definitely asked.
I don't think you could have set me up any better. I didn't pay her to ask that question. So Rackspace, I didn't talk much about it today, but Rackspace has a philosophy that we call fanatical support. Fanatical support is the idea that support should be something that's available, that's included, that is not an afterthought. It's something that's part of the solution and the software and the technology. So obviously with the services that we offer in the public cloud, we include support. With the private cloud that I mentioned, we will certainly support you if you choose. And support is an entirely different experience at Rackspace than what you'd find at the cloud, whoever that is. But I think I'd urge you to come check us out. Go to our booth. We have a booth out there in the, what do they call that thing?
The
Expo.
Floor.
Cloud Expo, the Expo Hall. In the Expo Hall, we have a booth there, and the Rackers there would love to tell you about fanatical support.
Question on the far left there.
So I don't work for Amazon, but I've got a question about their storage, their Glacier storage and their S3. They claim 11 nines of reliability. Some people scoff at that, 4 to 6 copies. Just I want your opinion, given Hurricane Sandy and how many backups have maybe been lost. It makes sense to have 11 nines of reliability, it seems to me. What's your opinion on that? And what do you see cloud providers doing in that area?
Well, I think every company that stores data in the cloud has a different expectation in terms of performance, reliability. I don't think that the world is going to solve cloud storage with a sort of a one-size-fits-all model. So some companies are going to be very attuned to reliability as their number one priority. Others are going to say, well, I need performance. I need local performance. I need it to be close by and reliable. Those are, maybe reliability comes second. So I think my answer on that is yes, it should be reliable. The software that we've built within OpenStack is configurable in terms of the amount of reliability that you need. It's also portable in the sense that you can build a storage cloud anywhere you need it. So you may end up with a storage cloud on-premise for performance reasons, and you may have a storage cloud that's served by Rackspace or somebody else, and you may end up using 2 different clouds, 2 different vendors. And I think that's yet another example of the power of an open platform versus a closed. If you're integrated with a proprietary vendor, you're sort of beholden to their idea of reliability and performance. But with open cloud, you can take your data elsewhere, and you get to choose who's got the right price model, who's got the right performance, and who's got the right reliability. So, I don't know if I answered your question exactly, but yes, clouds are going to have characteristics that help people with problems like Sandy and these outages, because they have the choice now to put their data outside of the walls of their environment, and I think that's a good thing.
Question from the front here.
Yeah, it's a good segue in terms of move your data anywhere. We look over the last 5 years, and the storage capacities have just skyrocketed. Computing power has gone up. What hasn't gone up so much is the communications capability. And when I want to take a few terabytes of data from one region to another, from one region to another, or applications like medical imaging, in which I may have thousands of MRIs at 700 megabytes apiece.
Right.
What do you see in terms of the network capacities, particularly in the U.S., and how can they be increased to an amount that will enable the kind of applications that we want to see with big data?
Yeah, so the question's all about communications. That's maybe the last bottleneck that we have in terms of true cloud adoption. You can't solve the speed of light problem. So the latency that we sometimes have issue with. You know, we're maybe someday we'll solve that problem, but so far nobody's come up with a solution to really solve the latency. But the bandwidth does considerably go up every year. I just saw an article that they're talking about shooting laser beams down, you know, fiber optic lines, and they're going to start to swirl, you know, to spiral them so that you can embed 3 or 4 or 5 different light sources and different laser beams and different wavelengths. I don't think Rackspace is going to solve the bandwidth issue. It is going to continue to grow at a sort of a steady rate. But I think the power of OpenStack is that you could run your own cloud to have your medical imaging close by in a private cloud, and then you could stream the important data to a third-party cloud like the other gentleman was asking about reliability. You don't want all your eggs in one basket. You don't want it all in one place, and you may need to solve different problems. I think private cloud helps people solve problems in one way. It brings the cost down. It brings the latency down to have a private cloud, and then you can, you know, stream your data to the public cloud over time, over the long term, to have reliability and an off-site backup. I think that's the thing that maybe helps people in the meantime, but there's no, I don't see a technology on the horizon that's just going to solve all of our bandwidth issues. I think that's something we'll continue with for a while.
Last quick question.
John, obviously Rackspace is the founder for OpenStack.
Yes.
And the software you develop, how do you draw a line between what you contribute to OpenStack and what is Rackspace IP?
Everything is, Rackspace does develop some software that we don't contribute back. Things that are integrated with our back-end billing systems, sometimes those are things that we don't contribute because they don't make sense in the open source project. Some of the things that we've built that make the Rackspace support experience better, that's our unique aspect in the cloud. It's not the hardware or the software behind the scenes, it's the product that we offer, the bundle, the packaged offering. So I think when we think about software that goes into OpenStack, most of it does go into OpenStack. We're consuming a version of OpenStack that's about 2 weeks behind the trunk, and most of what we're using is OpenStack as pure as it can be. There's a few things that we hold back because they're unique to us, and they probably always will be, but we try our best to make sure that most of what we build goes into the OpenStack project. It helps us because then we're not on a fork of OpenStack. We're on the main line as much as possible, and we try to make sure that the OpenStack ecosystem is getting the benefit of all the things that we're learning. I think that's a huge sort of another story maybe for another time, but the idea that we're learning to build clouds at massive scale, and everybody that consumes OpenStack is the beneficiary of that. And you know, they're basically never going to trip over the same bug twice because we've already, you know, tried it out in the public cloud. So I think probably we'll end there on that note, and thank Jeremy for having me.
We'll actually end on a much happier note,
Yeah.
because a little known fact is that the louder that people thank a Keynote by applauding, the more readily he comes back to Keynote again. And I want to hear John at every Cloud Expo. So let's please say thank you extremely noisily. Thank you, John Engates. Thank you, Rex.